Good day, everybody. How are you all doing? Today, here it is cloudy. The weather outside is dark, gloom and dark, and it's raining most of the time today. Although it is third week of May, but it's still a little bit cold outside. So let's get started. Let me start with my traditional jokes about statisticians. So, why does a statistician love to drink? Because we want to find the modes. And why did a statistician win a lottery? Because he knew all the odds in their favor. Kidding aside, let's start about talking about something new in statistics, something that we did not talk before. So let's get started. So today we are going to discuss a situation applying the empirical rule in statistics. So the key is the empirical rule. Empirical rule. We will do application of that. So here is a problem. Let me write the problem. Okay. They say, in a recent survey of 655 adults, it was found that the average amount spent on lunch was $44.60 with a standard deviation of $2.81. The amounts spent on lunch can be assumed, this is the key thing, can be assumed to be normally distributed. To be normally distributed. That means the amount spent on lunch is a bell-shaped distribution, which I'll show to you in soon. Okay, in a minute. Question is estimate the percentage of adults who spent between $44.60 and 47.41 on lunch on a weekly basis. On lunch. This they did not say on week or what. So we will not say anything much. Okay. So, since you have reached so much, I appreciate that. And I appreciate that you are watching my video. And please do not leave right away because I will go through the solution, try to explain it in a funny way, in an interesting way. And please do not forget to subscribe to my channel by hitting the red subscribe button. And at the same time, please click on the bell button so you'll be notified every time I upload a new video. So let's get started, okay? Shall we? So let me change the color of my ink and maybe I should go to a contrasting color of purple, maybe. Okay. So they're saying that the amount spent on the lunch can be assumed to be normally distributed. Okay, normally distributed. So that means it's a bell-shaped distribution. So that means the probability distribution. Let's draw the probability distribution. Probability distribution of money spent on lunch. Spent on lunch. As I told you, it is normally distributed. So that means if we draw the probability distribution, so we have the amount spent on lunch on the horizontal axis, spent on lunch on the horizontal axis. Oops. This is, I want it on the horizontal axis. So, and we have a probability density curve. So probability is on the vertical axis and it is bell-shaped in distribution. Okay. The value on the horizontal axis where the peak or the relative frequency of lunch money is the highest is where the center of this curve is. Can we not make it straight? Let me try. So we will erase this. And let's keep it like this. Okay. So this is where the peak is the highest. And this is your value on the horizontal axis is mu. Now mu was given as, if I show you one more time, is 4460, standard deviation is 281. So 4460 is the mean, is the value on the horizontal axis where the relative frequency or probability is the highest, and comma sigma is 2, standard deviation is 2.81. So mean is where most of the data is located, is the center of the data. The standard deviation means an average variation around the mean is $2.81. I also told you in the beginning that the empirical rule is the rule that has been observed over many years of data collection, bell-shaped distribution, or normal distribution, and it states, so empirical rule, one of the key tenets of empirical rule is 95% of the data will fall within two standard deviation, within two standard deviation, within two standard deviation. of the mean. Now we already know the mean, right? The mean is 44.60. We even know the standard deviation. Now, okay, and we also know now 0.41 of the mean. And the other, if we move it a little bit up, so basically empirical rule, as I said, 95% of the data will fall within two standard deviation. This is one of the postulates of this empirical rule. The other is 68% of the data will fall within one standard deviation, fall within one standard deviation of the mean. One standard deviation of the mean. Deviation of the mean. Of the mean. Okay. Now if I move this a little bit up. So if you notice, my mean is 44.60 and sigma is 2.81. These information are given. So if I do mu plus sigma, to the mean I add 1 sigma, I get 44.60 plus 2.81 is equal to, what do we get? 1, 4, and 47.41. Similarly, if I do mu minus sigma is 44.60 minus 2.81, which is equal to 9, 9, and then 7, and 3 is 41.79. Okay. So if I move this a little bit up, the question was between 44.60 and 47.41. Okay. So you notice 47.41 is on the right of the mean. Let me change the color of the ink again. And let's go on this color maybe. Yeah. Okay. So I go on the right of the mean, one standard deviation. So I locate the point on the horizontal axis, which is 47.41. And below the mean, I locate another point, one standard deviation minus mean is 41.79. 41.79. So if I draw two vertical lines from here to meet the bell-shaped curve, this area is 0.68, and this comes directly from the empirical rule. We also know that the bell-shaped curve is symmetric. That means I can take that 0.68 and divide it into two equal parts. So if I do that, this portion is 0.34, 0.34 from here to here, and similarly this portion is 0.34. Why? Because they're symmetric. So 0.34 is on the left of the mean, or 34% of the data is on the left of the mean, between the mean and one standard deviation below the mean, and 34% of the data is on the right of the mean, one standard deviation above the mean. So the question, if you remember, asked us what percentage of adults who spent between $44.60, which was the mean, and one standard deviation on the right of the mean, which is 47.41. So we can answer the question. Since 44.61, 47.41 is located one standard deviation above the mean. One standard deviation. Oops. One standard deviation above the mean. One standard deviation above the mean of 44.60. The percentage of people who spend between 44.60 and 47.41 is 34%. Again, to summarize, what I did was I draw a bell-shaped diagram, the center of the curve where the peak is the highest. Remember, this is the probability density curve of the amount of money spent on lunch. So probability is on the vertical axis. The center where the peak of this density curve is the highest, mean is 44.6, standard deviation is 2.8. Empirical rule states that if you go one standard deviation on the right of the mean, one standard deviation on the left of the mean, you get 68%. That is the empirical rule. So you locate the center 44.60, move one standard deviation on the right, it is 44.60 plus 2.81 is 47.41. Similarly, you locate the center, move one standard deviation on the left, as I show in the diagram, to 41.70, 34, another 34%. Why? Because the bell-shaped curve is symmetric. That means the left half is equal to the right half in area. Okay? So that means 34% of the people spend between the mean and one standard deviation on the right, which is 47.41. That is the answer to this question. I stop here. If you have any question, you please ask me a question, write it down, or you please give me thumbs up if you like the video. I appreciate that. That motivates me to produce more interesting video just for you. Okay, so if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will be back tomorrow with the second part of this problem. So please do not forget to watch me tomorrow. Thanks for watching. Take care. Have a nice day. See you next time.